This video is about the second sort of bend sensor that VPL developed, which was discussed in the first video on the patent. This version uses a fiber optic inserted into a tube and then moved relative to a light sensor that is at one end of the tube. The bend sensor has two parts. On the left is the sensitive element whose main structure is an opaque tube, and on the right is the emissive element whose main structure is optical fiber. On one end of the sensitive element is a felt light shield with a hole in it, and on the other end is a photoresistor. The emissive element has a red LED and a cheap plastic optical fiber inserted through a hole to make contact with the LED. The fiber of the emissive element is inserted into the hole in the felt of the sensitive element and can move freely. After mounting in the measuring tool, we can see that as the sensor is bent, the fiber retracts from the sensitive element. The amount of light cast on the photoresistor must therefore decrease as bend increases. As a result, resistance of the photoresistor increases as bend increases. Partially, this fall off of light is due to the inverse square law, but the interior of the tube does confine the light and limit the effects of the law. Most of the decrease is due to the dark walls of the tube absorbing the light as it bounces repeatedly. Here we can see the relation between bend angle on the x-axis and measured resistance on the y-axis. 3 tests were made, and the measured resistance values were extremely similar between the tests, so much so that it's almost impossible to distinguish the lines for the different tests. The relationship is clearly mostly linear, with a slight upward curve, owing to the predominant wall absorption and small contribution of inverse square law fall-off. Well, that's it for this week. See you next time.